In exercises 3 through 8, we're asked to use the graph to estimate the open intervals on which the function is increasing or decreasing, and then to find the open intervals analytically. Well, just from looking at this graph here, we can tell that it's decreasing what appears to be from negative infinity to x equals 3, and increasing from 3 to positive infinity. Now we're going to find this all analytically, which means using calculus and algebra. So we start off with our function y is equal to x squared minus 6x plus 8. And first thing we're going to do is, just as we did with absolute max and min, is to find the critical numbers. So that involves finding the derivative, 2x minus 6, setting the derivative equal to 0, and solving. 2x minus 6 equals 0, 2x equals 6, x is equal to 3. So that is the only place where the derivative is 0 or fails to exist. Since that's the only place where the derivative is going to be 0, then we know to the left of that it's got to be all positive or all negative, because if this is a continuous and differentiable function, the derivatives exist everywhere, and there's only one place where the derivative is 0 at 3, then it's either got to be positive or negative to the left or right. It's got to be either all positive or all negative to the left, and either all positive or all negative to the right. So all we need to do is pick some test values, any test values, it doesn't matter. If the interval includes a 0, that's always easy to do. And then we're just going to plug those values in. I usually write what I'm working with. That's the first derivative, y prime there. And we're going to plug those values into the first derivative, because we want to know if the first derivative is positive or negative on to the left and positive or negative to the right. So we plug in and we get y prime of 0. Remember what y prime is. Y prime is 2x minus 6. When x is 0, y prime is negative 6. So all I'm concerned about is the sign. If it's negative 6 there, it's going to be negative 6 everywhere to the left of 3, because we know it can't cross over the x-axis. It can't cross over 0, except at 3. Then we try y prime at 4. We plug 2 times 4 is 8, minus 6 is 2, and so that is positive. So positive, negative, it's going to be positive here. And that's exactly what it tells us. Now, some people like to go ahead and draw when the derivative is negative, it means that the function is decreasing. When the derivative is positive, it means that the function is increasing. So you can kind of see from the graph there, and we can write decreasing will be from negative infinity to 3, and increasing from 3 to positive infinity. Now you'll also notice something very important here, is that we have this relative minimum here. Relative min at x equals 3. Now notice something very important that happens whenever you have a relative minimum. The derivative changes from negative to positive. First derivative changes from negative to positive, and that means you went from decreasing to increasing, and therefore you have a relative minimum there. All right, we'll go on to number 5. And the only thing that's going to differ with these is the algebra needed to get to the critical numbers, and then what the different intervals, whether different intervals will be positive or negative. So we have y is equal to x to the third over 4 minus 3x. The derivative is 3x squared over 4 minus 3. We set that equal to 0. 3x squared over 4 minus 3 equals 0. We can multiply both sides through by 4, and we get 3x squared minus 12 equals 0. Factor out the 3. 3 times x squared minus 4 is 0, and we get x equals 2 and x equals negative 2 as our only critical values in there. Notice, there they are right there in the graph, 2 and negative 2. Now, we don't know which one is a maximum and which one is a minimum, but we do know that those are the critical values. So we go over and make our sign chart. This time we'll have two values, negative 2 and positive 2. That breaks the number line, the x-axis, into 3 intervals. We need to choose a test point from each interval, say negative 3, 0, and positive 3. And again, this is y prime that we're working with here. And we want to find out whether y prime is positive or negative in each of those intervals. So what do? We test y prime at negative 3. And let's see what we get there. Y prime, again, is right here. We plug in negative 3. Negative 3 squared is 9. 3 times 9 is 27. 27 over 4 is 6 something, so that is going to be positive. And we really don't care what the value is. You don't need to spend a lot of time figuring out. You just need to know that it's going to be positive there. Next, at 0, when x is 0, then very definitely y prime of 0 is negative. And let's plug in 3 into y prime. When we plug in 3, we get, again, 27 over 4, which is 6 something, so that is going to be positive again. So that means that we have increasing, decreasing, increasing. And if you look at the original graph, the graph does in fact tell us that it's doing that. So the function is increasing from negative infinity to negative 2, and from 2 to positive infinity. It's decreasing only from negative 2 to positive 2. And you can see again, we have a relative max and a relative min. The relative max occurs when the first derivative changes from positive to negative. So rel max occurs when first derivative changes from positive to negative. A relative minimum occurs when the first derivative changes from negative to positive. All right, so hopefully this illustrates what we need in here. And we'll go on to 6 to 7 through 8 or 6 through 8 in the next video.